Hi, this is our first lesson for our unit on radical functions and rational exponents. Trying to keep things similar to what you've seen in your classes at PHS. So there'll be some sort of agenda shared with you either in the video as well as in Canvas. Just a reminder, if you look at the top of this screen, you should have paper available to write on and participate along with all videos. And then contact your teacher if you have any questions regarding the daily learning targets or concepts that we watch in these videos. So again, this this unit is radical functions and rational exponents. And what we do in this unit is we extend our knowledge of roots, meaning we're going to understand things about square roots, cube roots, fourth roots, fifth roots, whatever type of root you can imagine. We will also learn how to add and subtract and multiply and divide different types of roots. And then we're going to also in this chapter learn how to solve problems that have rational roots or radical roots. And then we're also going to talk about some transformational graphs of radical functions. So our first unit or section today is going to just remind us about some graphing, and we're going to learn about how squares and square roots are what we call inverse functions. So if again you notice right here, we're going to determine some equations and some graphs for inverses today. This is sort of part of our solving standard as well as our representation standard. And again, we're going to go through some bell work together like we would in class, just some other examples, and then there's going to be a homework assignment posted in Canvas. Hi, so here's our bell work. It says graph the following power functions. And then it asks, are these graphs functions by definition? So take a minute, get out your piece of paper, just 4 graphs. What do these graphs look like? And then the second question is, are these graphs of functions? Again, we talked about functions in Algebra 1 and earlier this year. Are these graphs of functions? So take a minute to graph. So you've spent extensive time working on linear functions. That's what your graph for question 1 should be. Again, notice your specific point, 0, 0, 1, 1, 2, 2. We also spent a lot of time first semester learning about quadratics. Again, you'd have 0, 0, you'd have 1, 1, but you'd have 2, 4 if you square it. And likewise, negative 1, 1, and negative 2, 4. So are these graphs functions? The answer would be yes. They're functions, and the reason they're functions is each value you input for x gives you one answer for y. Same thing over here, every answer you input for x gives you one answer for y. Or as you might have remembered that we have this vertical line test. If I draw a vertical line through this graph, it's only going to cross the graph one time. 2 and 3, or 3 and 4, excuse me, we haven't talked about as much, but you should feel comfortable with knowing, again, this goes through 0, 0, positive 1, positive 1, and this would go through positive 2, positive 8. If I plug in negative 1, it would be negative 1, and negative 2, I believe that's negative 8. And again, a cubic function is that one, oops, that looks kind of like, I call it a snake. And then in question 4, again, 0, 0, 1, 1. If you plug in 2, 2 is actually going to be totally off your screen. 2 to the 4th is actually going to be 216. Same thing over here, negative 1, 1, but negative 2, it's going to go up so fast. Looks very similar to the parabola above it, but much faster going growth. And again, both of those, yes, are functions, because when you plug in a value for x, it gets one value for y, and that vertical line test holds true. So how is this related to our lesson today? Well, we're going to be talking about inverses, and we're going to want to know what's the inverse of each of these functions. So to talk a little bit more about inverses of functions, we're going to look at 4 more questions. Before we look up or talk about the questions, I just wanted to give you the definition of inverse. Again, it's something that is the opposite or reverse of something else. And again, in math, we talk about a reciprocal quantity as being an inverse. A mathematical expression or an equation can have an inverse. A geometric figure can have an inverse. And again, the synonyms are sort of opposite, converse, and again, all these other sort of pieces. So that's what inverse means. So again, if we talk about listing some inverse operations, again, you're thinking about sort of what is the opposite operation. So take a few seconds, write down the opposite operations of those four listed. It shouldn't take you long to figure out the opposite operation, obviously addition, subtraction, multiplication, division. And the two that we're going to be focusing on a lot in this chapter are the squaring and the cubing, because we just did that on our graphs. And so we want to know, what is this square root and what is this cube root? What do those graphs look like? How do we graph inverse expressions in graphs? And then again, how do we find inverse equations kind of moving forward? So our next few examples are going to be practicing that, and we're actually going to take a look at some of the questions on your homework and add a few examples. So if you haven't already gone into Canvas, you'll want to have either that homework assignment open and downloaded, or, and again, have your paper out and you can write it on a separate sheet of paper. You might also, if you have a printer at home, you could print out the assignment and kind of work along with the video. Whichever way you decide to do your homework is completely fine, whether you write it on a separate sheet of paper and notebook or if you print it out. But I'll give you a second to kind of get that ready. So this is the homework assignment for today. We're going to do one question that's on there, and then if you notice there's a second graph over here, I'm going to give you another question to write your work on, sort of indicating that you've been watching the video and participating in class today. So the first question says, graph each function and then its inverse. So we're going to start by just graphing this function. Again, if you're going to graph that function, you can do it any way you remember. So take a second and just sketch the graph of that function. If you're unsure how to graph a function, again, the easiest way is just to make a t-chart. Again, you can pick any values you want for x. So some people like to say, okay, well, I'm going to plug in 0. If I plug in 0, then 0 plus 2 is 2. I'm going to plug in 1. If I substitute in 1, 1 plus 2 is 3. If I plug in 2, 2 plus 2 is 4. But don't forget your negatives. If you plug in -1, -1 plus 2 is 1. If you plug in -2, you get 0. And then you just plot those points. 0, 2, 1, 3, 2, 4. And you should not be surprised that it's a straight line. So that is your original graph. Your inverse, let me change color. Your inverse, again, is the opposite operation, or in this case, the opposite of x and y. So the inverse, and I'm just going to squeeze that in right here, the inverse graph is take those x and y's, and again, because it's blue, these are still x and y's, and switch them. So instead of graphing the point 0, 2, we're now going to graph the point 2, 0, and 3, 1, and 4, 2, and +1, -1, and 0, -2, and see what we get. So 2, 0, 3, 1, 4, 2, etc. And you see a graph that looks like this. So these red and the blue graphs are both inverses. They're both actually functions. When it says label them, again, we can see that this red one is called y. You can't call the blue one y because it's a different graph. Sometimes you'll see it listed in f of x form. So instead of, they'll call this f of x with a little -1 here. If I go back to red, they would just call this equation f of x, and they call this one f of x with a little -1. So that's how you find the inverse graph. What if you want to talk about the inverse equation? I'm going to go back to blue. What if I want to know the inverse equation? You know, inverses are opposites, and so there are 2 steps to find the inverse equation. I'll write them up here. Step 1, just like when we did with our table, you're going to switch x and y in your original equation. So instead of being y equals x plus 2, it's going to be x equals y plus 2. And then step 2, get y by itself again, solve for y. So how do I do that? I'm going to subtract 2 from both sides. So I'm going to get x minus 2 equals y, or if you want to flip it around, y equals x minus 2. Notice the operations have changed. Over here it was x plus 2. Now over here it's x minus 2. These are inverse equations. These are the inverse, this is the inverse of your original graph. So what I'd like you to do is, again, I didn't put an equation here so that I could give you an example. So my first example that I'd like you to graph is, what if I gave you the equation y equals 1/2 x squared plus 3. So if I give you that equation, what I'd like you to do is I'd first like you to graph this equation. Then I would like you to find its inverse graph. And then I would like you to find its inverse equation. So I'm going to give you a few minutes to try that, and then we'll walk through. Feel free to pause the video at this point. So I picked some numbers. I might not have picked the same numbers that you did, but I do recognize this should be a parabola, and my parabola looks something like this. I got it to go through 0, 3. I chose 2, found out 5. I chose 4, found 11. Again, just substituting in, graphing this. So then let's do the inverse. To find your inverse, all you're doing is switching again your x and y to find that inverse graph. So instead of 0, 3, now I have 3, 0. I graphed it on here. Instead of 2, 5, I now have 5, 2. Graph that on here. Instead of 4, 11, I now have 11, 4. And again, if you don't have the same exact values because you picked 1, 2s, and negative 1s, that's fine. But you should see now what looks like a parabola, but it's opening up to the right. Now let's practice. Try to find its inverse equation. Again, following these steps, the first step is to switch x and y. So it would be x equals 1/2 y squared plus 3. Now I need to solve for y. So my first step would be subtract 3. So I have x minus 3 equals 1/2 y squared. The next step is to get rid of this 1/2. So I'm going to divide both sides by 1/2. Or I could multiply both sides by 2. Again, I'm kind of running out of room here, but I would have 2 parentheses x minus 3 equals y squared. And the last part is to get rid of your square root. You always square or square root only when you have that piece. Now, when you add a square root, you have to square root both sides and add the plus or minus. I'm going to rewrite that equation over here. Again, we have 2x minus 3 equals y squared. Now I'm going to square root both sides. When you add the square root, you have to make sure you don't forget that plus and the minus. So we have plus or minus. You also can distribute 2x minus 6 equals y, or flip it, y equals plus or minus the square root of 2x minus 6. Can't simplify any of those pieces. This is my inverse equation. So you have question 1 in this example. And there is questions 2 and 3 on this first page. If you're looking at the document in Canvas, there's also a whole backside for equations. I'm going to write 2 more equations over here so that you have a full, complete worksheet. So again, you have 1, 2, and 3 questions. We did an example above. The next question that I'd like you to graph and find the inverse for is y equals 2x squared plus 3. And then the last question down here I'd like you to graph is y equals, let's see, I want x plus 2 squared. So graph those 2 equations, find their inverses, and that will complete your assignment if you finish these two examples and then the back side of this worksheet. Check Canvas for more information on homework and how to submit it to your teacher. If you have any questions, again, remember to email or contact your teacher about those questions.